I welcome you all to this next session of our Big Data Analytics MCA3. Today, we are going to discuss the basics and fundamentals of data modeling techniques and its implication and importance under the Big Data Analytics. Let me share the screen with you. So we will start with the data modeling technique. The first of all, to discuss the data modeling, we will discuss what do we mean by the modeling itself. It's not a something related to the fashion and all that. It's modeling means to arranging, to organize a given resources in a meaningful way, in an accessible way. That is called as a modeling. And the data modeling itself is related to our management system, database management system, wherein we are managing, arranging, organizing that data in a meaningful way using some kind of schema, using some kind of tables, by imposing some kind of restrictions, constraints over that data, like primary constraints, referential constraint like a primary key and reference or foreign key, some kind of the data integrity constraint like the not null, it should be alphabetic or alphanumeric or numeric. And that's why DBMS itself is the first data modeling technique. Though it is not directly related to the big data, because under the big data, we are always dealing with the semi-structured and unstructured data. Whereas in a DBMS, we are dealing with the, or RDBMS, we are dealing with the structured data. That's why, though it's not directly related to the big data, but the evolution of data modeling is under the, like the RDBMS schema, a definition of schema, then the table structure, file structure. These all are the data modeling techniques. Then comes the big data management or big data analytics, wherein we are dealing with the semi-structured or unstructured data, and wherein we are using some kind of NRDBMS, non-relational database management systems, like the, you can have the graph based or columnar or NoSQL like query systems over there. And the data modeling techniques under the big data are the different one, wherein we are actually using that data and storing that data. Now this is the basic data modeling. That person John is there, is a friend with person Sally, both are the person, means the object class is a person, has read, both have read the books called as a graph databases. That is the data modeling. We are expressing that relations between the instances, relations between the objects, classes, and their activities with each other, their interaction with each other using some kind of model, and that is the data modeling technique. Basically, it's a data modeling technique. Now, what are the key steps in a data modeling process? How to achieve the data modeling? The very first step is to identify the entities. First, we have to identify the entities under the given domain of business, under the given domain of that particular organization, and that are represented in a data as set as per the model. Means that entities will be represented as a model in that particular data set. That is the basic. Then the second, identify the key properties of that entity so that you can differentiate between them. That data models can be differentiated, entities can be differentiated, as like in the previous that these are the person, these are the data model. Two kinds of data models are here, one is a person and another is a book. Okay, you can identify the person by its name, his or her name, or we can identify the book by its name again, but it's a book's name and here it is a person's name. That is identifying of the key property. Then the third key steps in the data modeling process is a draw the rough draft. Means first we have to see what kind of relationships they are established in under that data set between the data models, between that particular entity. That is the entity relationship model. to show the connection between the entities. That is a rough draft. Then the fourth step is to identify the various data attributes that need to be incorporated in the data model. Means we have to first identify the various data attribute. Means suppose the person is one data model, a entity in our data set, nomenclature we are terming it as a data model. Then that data model must have some attributes, like that person might have attribute like suppose his name, his address, is suppose the social any particular Aadhaar number or PAN number, that's identification attribute or primary attribute, unique attribute. And accordingly we have to identify the attribute. Or book can be identified with the attribute of the books. What can be attributes of the books? Books can have the attribute like book number, accession number, number of pages, title of that book, author of that book. These are the attributes, or pages, or might be a publication of that book. That is, these are the attributes related to that particular book. ISBN can be the unique attribute of that book that can be termed as a primary key. Then the fifth step, map the attributes. Okay, that is a mapping attribute to entities so that the model properly reflects the business meaning of the data. Means you have to map the attribute. That is a referential integrity now. Means which book is read by the Sally and John. That's a graph databases. Okay, both have read the book. Yes, that is a both have read the book. These are the mapping of attribute. Okay, now this is the mapping in our entity relationship diagram. We are having the mapping constraints like one-to-one mapping, one-to-many, many-to-one, or many-to-many. These are the mapping types, and that's how we can map. That should be the map the attributes. That is one of the key steps in the data modeling process. And the last key step of the data modeling process is to finalize and validate the data model. To finalize and validate the data model, and then refine it to keep up to the date as per the data changes. Means we have to again finalize, we have to validate that data model again and again, and we have to keep that data model up to date. Means updated, upgraded as per the state of that data. As and when data changes, you should change the data model attribute. You should change that particular attributes. Now, this is, you can say, the waterfall model of the data modeling process. The first, we have to select the business process. For which business process we have to model the data. Data model has to be established. For what purpose? For which purpose? That is why that process is there. Then declare the grain. How much means under that domain? Which is the key focus area? Which are the entities? Which are the data model? Which are the attributes? Accordingly, identify the dimension 3Ws. 3Ws means what? When, how, and where. Means that 3Ws has to be answered by the organizer of that data, organizer of business process, organizer of data set, data modeling, developer of data modeling, to identify the dimension. Then identify what actually that data model means, for what purpose that data model should be there, and what that data model is representing. That should be identified. And accordingly, all these steps, at the last step, for that data model, we have to build, developer has to build the schema for that data model. That is a waterfall model of the data modeling. We will move further. Now these are the some kind of the data analytic techniques we are discussing. The time series analysis is there, then the simulation, we have discussed this all. Social network analysis, supervised learning, that is a machine learning, sentiment analysis, signal processing, AI, we can say, statistics, regression analysis, spatial analysis, predictive modeling, here comes the modeling, unsupervised learning, pattern recognition, and visualization. These are the some kind of the data analytic techniques using which we can develop the schema for the purpose of data modeling. Now this is a block diagram of data model. how you can develop the data model. First, there should be the your business, means your organization, your key area, focus area, data set, whatever you can term it. That should be, it should be at a reduced risk and reduced cost, business opportunity, increase effectiveness and responsive to change. That should be the attributes of your business. Then it should support data model. It's actually from bottom to top diagram. Data model should support the system data, system and data, and system in turn should support your business. Okay, that's how we can have the block diagram of the data modeling. I'm going to share this at our classroom, Google Classroom, and group also. You can learn through that. Before moving towards to the next slide, we will see one small video related to the data modeling.
In this video, you'll create the foundation for your
I hope video is audible and visible to all of you. If there is any problem, let me share through the, please share through the
clinic's
chat box.
custom app by
Mark your
learning about
attendance
relationships. You'll also create an entity relationship diagram, or an ERD. While planning your custom app, you created the following goal statement. Design a mobile app for therapists to record services delivered to clients.
That is the WS type question we were discussing, for which purpose and for whom and what to design. That's a mobile app to design for the therapist and for the purpose of recording their services delivered
during their visit. And based on that statement and the needs of your clinic, you identified 3 tables of data: client, visit, and service.
These are the data models.
The next step is to identify how these tables relate to one another.
Entities.
Start by looking at the client and visit tables. One client can have multiple visits over time, but each visit belongs to only one client. This is called a one-to-many relationship. When creating your data model, use a crow's foot to represent a one-to-many relationship. One client, many visits.
Relationships.
In order to relate these 2 tables, each visit needs to know which client it belongs to. But using something like a name or a combination of fields can be problematic. What happens if there are 2 Jane Smiths in the client table? It becomes unclear which Jane Smith went in for the recorded visit. Or what if Jane Smith changes her name to Jane Doe? The visits would no longer match up, since the visit record still shows Jane Smith as the client name.
Means you should have the,
and a misspelling in either table would also impact the matches. Instead, using a unique value that always exists and never changes solves the problem.
That's a client ID.
When a unique value is used, it's called a primary key. This means that the client table will only have one record that identifies as client ID 101, who in this case is Jane Smith. The client ID will be unique and only assigned to Jane Smith. If that value is referenced in another table, that's called a foreign key.
That's a referential integrity we were discussing in our PowerPoint presentation.
Client ID 101 in the visit table is foreign because it did not originate from the visit table. It was unique to the client table. You'll see that client ID 101 repeats in the visit table to track every instance the client visited the clinic. As a best practice, it's a good idea to have a primary key in every table, even if you don't expect to use the primary key in a relationship. This prepares your tables for potential relationships as your custom app grows. It can also be a great way to reference any specific record during development and when troubleshooting. Another best practice to help you identify when a foreign key is needed is when you see a crow's foot in your table relationship. This is a good indicator that you'll use a foreign key in that table. Similar logic can be applied to services. A service can be defined as the actions the therapists take during a specific visit. While services are tied to a client must come into the clinic for a visit in order to get the services. One visit can have multiple services, but each service belongs to one visit.
That is one-to-many constraint under the data modeling mapping constraint.
Just like client to visit, the one side uses a primary key. The visit and services table are related by the visit ID, a unique identifier for each visit. A client can have multiple visits, and a visit can have multiple services. By drawing out your data model using tables and branching lines, you created an entity relationship diagram, or an ERD. An ERD will become the foundation for building your custom app in FileMaker Pro. While writing out a plan helps describe the business problem, drawing out an ERD helps to explain what tables are necessary and how those tables will relate to one another. In this video, you learned about the one-to-many relationships between clients and visits and services. You also learned to create primary keys and
that is with respect to the data modeling. We will come back to our presentation. We were discussing what do we mean by the data model. Yes, we were discussing that key steps in the data modeling processing, that we have how to have the entities, then draw a rough diagram, then identify the various data attributes as like the primary key and foreign key, and finally validate and keep up to date the data model. That's we have seen. That's a data model block diagram. Now, why data modeling is essential? We are discussing this data modeling with respect to the big data, wherein there are the semi-structured and unstructured data are there. Data from various heterogeneous sources are there, like there might be a data from social area network, there might be any data from the video streaming, there might be any data generated through the chats, and their heterogeneous types will be there, and there whatever the data sources are there, they will be like unlike to each other, and due to that there should be the physical modeling for the big data. That is the first step. That's a way, there should be the physical modeling of the big data. For the purpose of accurately modeling all types of data at a rest within the organization. As we have discussed, it is I have shared with you that data can be of any type. That's all type of data should be at rest. Should be at rest means should be stored within the organization. It should not be just the RDBMS resident data, like the structured data, as we have discussed under the RDBMS, there is a structured data only. Here in the big data, there is moreover the non-structured data, unstructured data, semi-structured data. That's why it's not just the RDBMS resident data. Third point, document physical metadata, table space, partition, etc. Means whatever you are storing, there should be under the some particular metadata format, and then you can have the particularly applied or introduce of some particular non-RDBMS, NRDBMS data stores like NoSQL, JSON or Hive. These are the some of the examples of the you can say the NRDBMS systems, as like in the RDBMS system, we are discussing the examples of Oracle, Microsoft SQL, PostgreSQL. These are the examples of RDBMS. These are the wherein NRDBMS can be a NoSQL, can be JSON or Hive as per your storage type. Lastly, we have to build many physicals based on the business decomposition as per your physical requirement, business requirement, or functional requirement of the business. There might be number of departments generating semi-structured, unstructured data or big data. Then you can have you have to build number of many physicals, and accordingly you have to last the reverse engineering. What do you mean by the reverse engineering? You have to keep this process going on again and again. It's like a circular process, okay, and you have to keep it going on again and again. That is only shown in our diagram. That's a modeling for the business. First you have to understand the landscape means the what is the domain of that business, what are the actual requirement of that system, and you have to then identify the heterogeneous and big data physical models. For that purpose you have to develop agile development means which is a continuous and contiguous development. Identify the data modeling techniques for that purpose, and you can have the self document business. That is a ongoing and process, okay, it's like a circular process. Okay, then what are the limited data modeling and big data modeling? In a limited like a RDB or a regular database management system modeling, there is a classification as like we are classifying that table, which is a master table, which is a transaction table, or classifying the attributes also, like some of attributes are the foreign key attributes or the referential key, or some of are the primary key or unique key attributes. Then the regression is there. Regression means you are deriving one table from the another table. From master table you are deriving the transaction table using some kind of relationship. You can also have the clustering possible in the limited or regular or traditional data modeling, clustering of the all master entities, clustering of the all weak entities. Weak entities means your relationships. Then unassembling techniques are can be there, and you can use the resampling technique. Means if suppose any sample goes well, any particular system goes fail, you can resample that technique again and again. That is possible in your regular RDBMS. Whereas in a big data modeling, you can have the representation learning. As like representation learning means what? You can represent the data sets over there. You can represent us from which data source, what kind of data is there, like from the social media network, there might be audio visual data. Suppose from the chat box, there might be the text data, that is a representation learning. Then the deep learning, what is the content of that data. Okay, in the first point we have talked about the type of that data, audio visual and text, these are the types. Now the deep learning means what actually the content of that data. For that purpose you might have to apply some kind of algorithms like the map reduce and other algorithms, or some machine learning algorithms, due to which you can achieve the deep learning. Then the distributed and parallel learning. In the some of the last sessions we have discussed scale up and scale out techniques under the big data analytics. That is nothing but the distributed and parallel learning, transfer learning, active learning, and kernel based learning. These are the some of the data modeling parameters, or you can say the benefits of the data modeling, wherein we can achieve the transfer. Active learning means what? As we have seen, it's a continuous procedure. You can have the active learning. Transfer learning means what? You have to always transferring, you have to keep always transferring data. Okay, transferring data means not just from the one source to the another destination. It might be intra source, intra destination, or internal or external transferring. That's how to do. That's a data modeling parameter. And kernel main base means what actually the your key or focus area, kernel area, depending on that for which purpose that data modeling is being done. That is the big data modeling and limited data modeling comparison. Now, what are the significance of data modeling? The first significance of data modeling is the understanding the business requirement. By applying some kind of data model, we can understand the business requirement more precisely, and we can work upon that, or we can work for that to achieve that goals and visions of that business or requirements of that business. Secondly, we can have the robust design elements under the data modeling. We can apply that design elements for the robustly to achieve that goals. Third, consistency across the project can be achieved by using the data modeling. Then the better data quality can be maintained. Fifth, you will require lower maintenance. Obviously, big data management, as we have discussed many times, it's at the, or it's using the NRDBMS, no SQL, or structured or semi-structured or unstructured, means any kind of data can be stored. Obviously, it will require a lower maintenance as it's being used under the cloud computing techniques. Reuse of the model is possible. You can reuse the model, which may not be possible in a traditional data modeling like RDBMS. We can have the improved performance, and depending on this, we can manage the quality. That's the last 8 point of the data, and we can achieve the quality management by applying data modeling techniques, robust data modeling techniques. Being this is the very first part we are discussing, these are the basic types of data model, like the DFDs are there, ER diagrams are there, UML diagrams are there. These are the some kind of the data modeling perspectives. As per the different perspective, we can achieve or we can design the data model. Maybe some object role models can be there, and we can describe the data accordingly. Obviously, these are the basics one. These are data models are the basic one. We are not supposed to study this data model. We are supposed to study the data models under the big data management, like the MongoDB and other, or columnar database or graph databases. And that is nothing but the data models under the big data. We will discuss that in the next session. We'll continue with the basics at this session only, and the next session will be dedicated to the types of data model under the big data. What actually data science process suggests us? Okay, this is the basic block diagram of the data science project. First you have to obtain data, then scrub that data, then explore out of that data, define the model for that data. Here comes the data modeling, and accordingly that model you have to interpret the outcome. Okay, you have to interpret what that data model is suggesting, for what that data modeling is representing. That is an interpretation of data modeling. Okay, that's how we can obtain, then scrub, explore. These are the internal processes. Modeling, here comes the representation of the data in the under the using some kind of data model, and depending on that you can, or user should interpret the data or gather the data from the relevant sources, that is obtained, then the clean data to format that machine understand, that is a scrubbing of data, then find significant patterns and trends using statistical, that is exploring or analysis of data, construct model to predict and forecast. This is, here comes the big data. These are the two parameters under the big data. We have to predict and forecast using big data and put result into the good use, that is the, you can say, the interpretation. Next slide. We have discussed this slide in some of the before sessions also, that 4 types of data analytics, wherein as the value increases on the y-axis, you can see as the value increases, the complexity increases, the types of data analytics explode. The basic data analytic type is a descriptive, wherein we are getting the answer back with respect to the what happening in my business. Then the diagnostic, why it is happening. Okay, that is the value increase, complexity increase. See again the XY axis. Then the predictive analytics, what likely to happen, that is the prediction with respect to the future. And as the value and complex will be going on increase, we can have the prescriptive data analytics, where we can have what do I do need to do, means what should be the my role as a user, as a stakeholder of that business, as a stakeholder of that particular data model or that organization or functional department. What should be the my role, what do I need to do. That are the these 4 are the basic types of the data analytics, for which purpose you have to implement, we have to design the data model accordingly, wherein we can achieve descriptive, diagnostic, predictive and prescriptive data analytics procedure. Now this is a basic diagram of the business data model, business model integration. There is a one business, suppose that's a data model. You can replace this business word by the data business model. You can have under that business model, you can have the processes of that business. Okay, and data used by that particular processes under that business process model. Then the data model, you can have the number of processes, you can have the number of homogeneous or heterogeneous data. For that purpose, you should have the some logical model. You should also have the some physical model for that particular data, that is achieved through the input and output data structure. Then the database generation can be there. Using that process and data model, we can have the requirement document, what should be the, which process will require which data and how it will process, or how the data will be processed. For that purpose, it will require some pseudo code, some application prototypes as per the user view panels, and application using some application program. Application prototypes can be developed, and that all in together collectively will be the business model integration. I'm going to share this PDF at our Google Classroom. Now, what actually, why should be the big data model should be there? What is the use of that big data model? It will empower the user under the for the purpose of accessing all business data, like suppose the other parameter like images, audio, videos are there using some kind of particular platform. That is the purpose of any big data modeling. That is something we will again see the one basic video of the big data. Let me stop this share and we will see the one more video, basic video related to the data modeling under the big data. I am going to share all these videos at our Google Classroom. This is under the Oracle data modeling concept under the Oracle.
With Oracle Data Modeler, I can present business data for analysis that reflects a structure.
It will give you an idea about how the data modeling is implemented under any particular DBMS or like any particular SQLs, data storage systems.
My business and enables me to create queries in the same way I ask business questions. Let's take a look at how to use Data Modeler to review source objects and build and publish a data model. I can review a source object by selecting it from the database pane, and then use the Overview tab to review the columns and the Data tab to take a look at the first 25 rows of data. A table with the check mark in the database object list tells me that the table has been added to the data model. Fact and dimension tables contain not only the Overview and Data tabs, but other tabs pertinent to the data as well. For example, the Customer's Dimension has a Hierarchies tab. Hierarchies roll up from lower levels and show me the relationship between dimension attributes. To begin adding tables to a data model, I start by locking the model, and then I pick the source and specify how it is to be added. Data Modeler can recommend fact and dimension table columns for me, or I can design the tables myself. I name the fact and dimension tables to meet my business needs. Add the columns, and pick the column that joins the two tables. Joins indicate relationships between fact and dimension tables in the data model. Data Modeler will create two views, one fact table, one dimension table, and one join. Next, I perform some maintenance tasks, including changing the names of the columns in the prod revenue table, verifying that all the columns are available for edit, renaming the columns to make them more user-friendly, and then adding aggregation rules for the measures.
Okay, that's how
Two measures
the
are
Oracle data modeling is being implemented. We will again come back to the presentation. We'll recap the what we have discussed in this session. Okay, this is a big data modeling, big data. Then what do you mean by the data modeling? A basic data modeling under the RDBMS like a ERD, UML, database, DFD diagrams, etc. We have discussed. Then what do you actually mean that data modeling itself? Then the key steps under the data modeling process: identifying the entities, identifying the key properties, drawing the rough draft, identifying the various attributes like the parameters of that entities, fields for that table, mapping that attribute, that's a referential mapping, and finalizing and validating the data model and keeping it up to date. These are the key steps under any data modeling processes. This is a waterfall model of the data modeling. First, we have to select the business domain, then declare the what that domain is meant for, how much it is weighted, then identify the 3 Ws under that domain. That's so when, how, and for whom. Then what is the purpose of that particular domain or that particular business. and accordingly we have to build a schema. That's a schema for the data model. These are some of the data analytic techniques for which we have to build schema for their data modeling. This is a block diagram of data model. Data model should support the underlying system and data, and that in turn should support your business. That is a bottom to top reading of that diagram. Then why the data modeling is essential, that we have discussed. Reverse engineering, that means data modeling is a continuous procedure. Then the comparison between the limited and big data modeling. Significance of the data modeling we have discussed, like quality management, reuse of the models, understanding the business requirement, consistency across the project. These are the basic types of data model as we have discussed. These are basic traditional like the ERD, DFD, UML, but we have to discuss the data model concept with respect to the big data analytics at the next session of this particular topic, wherein we will discuss conceptual, physical and logical schema or logical data models and other data model like graph, columnar and database. This is the data science process we have discussed. Obtain the data, scrub the data, explore and analysis that data, accordingly define, design, implement the data model for that purpose, and accordingly interpret from that data model. These are the 4 types of data analytics. Descriptive, which is the basic one. Next to it, somewhat complex, is diagnostic. Next to it, somewhat complex, is predictive. And next to it, and most complex, is prescriptive. That's the complexity and value against the X and Y axis. This is a business model integration. And what is the purpose of data modeling? That is something with respect to our today's session. We will continue the types of data model at our next session. Here I conclude our today's session. I wish that many of you are not attending lecture. Please convey that these are the lectures meant for all of you. You should take the benefit of. Thank you.